Sorry for that. Ooh, dropped something on the keyboard. Get those really annoying ads. So what's up with those? Oh, come on, my microphone is always reducing the gain for some reason. Okay, we really need to fix this thing as well. Yeah, we'll crop it a bit. We will crop it. Yeah, this should be better. Shall we crop the URL as well? I don't know. Probably should crop it as well. Crop, crop, crop. I'll just pop it in the link. I'll just pop it in the link. It's the filter. Should have filters for. Yeah, we have a filter and a gain. Gain is doing something funny. Let's put the gain to 3 or something. Make the gain a bit higher. One sec. Oops. Yeah, say again. Yep. Sorry, what's the question? Sorry, wait, just don't know. What? So we're measuring beats per minute. It's blood heart rate. It's heart rate. So it's measuring heart rate. If I don't move, it will actually start measuring. It should show me 64, 65. If I stop moving, let's test this. Should actually probably stop talking as well. Okay, now we have a fair quality, good, fair signal, 70 BPM, 64, 63, and it's 66, 65. So it's close enough. Close enough. Close enough. It's close enough. Yeah, it's measuring your heart rate through the camera. That's right. It's science magic. Science magic in action. I have to control for light. Control for light. Probably need more light. Probably be a bit better with more light. Bit better with more light. If we don't move for a while, it should give us a reading. Magic, science in the works. Wait. Yeah, now we're getting a really strong signal. 63. Yeah, as soon as I start talking or moving. 63, 64, and what is it? 64. Precise, precision. Precision in the works. So we are developing these web applications. They're all available on our website, BioniChaos.com. Go check it out. We have a lot of these tools. We have prosthetic arm, interactive simulation, EEG, signal generators, things like that. I guess someone is asking what else can it do? So as if measuring blood pressure. Well, it's not blood pressure. Blood pressure will be systolic, dystolic. Actually, you probably could get systolic, dystolic measurement from it as well because it's PPG. It's essentially like PPG. So you could potentially get systolic, dystolic. I mean, yeah, because you'll need to look at this notch, the dichrotic notch in the waveforms, which is maybe there, probably not. I think I can see it. Yeah. So you could potentially extract, upper, lower numbers as well, but yeah, you'll need a lot of luck. Probably better camera controlling for light, things like that. Better. But yeah, but normally you will need like whatever $100 worth of smartwatch to measure your pulse. This one you can use your webcam only and web browser. So magic happens. Fraction of the cost. So let's see if there's any more questions. Wait a sec. So we make this web application ourselves on our YouTube channel. We make those live stream the development process, and by the end they are available on our website, which has the same name, BioniChaos.com. Same name as the YouTube channel. Let's see. BioniChaos.com is the website, and the same whatever hashtag BioniChaos 1C. I can show it on the BioniChaos. Where is the name? Can't see the name. Oh, I think it's stuffing up my. What was the good? Well, I shouldn't touch this. I shouldn't touch that. I shouldn't touch that. Because it messes up my camera. I'm streaming my camera to the thing. Wait. All the links should be in the chat and everything. Wait a sec. Oh, come on, I'm really bad at this. Okay, I'm really lost. What am I? Where am I? Who am I? Why am I? Hybrid AI human. Let's mute it for a sec. I'll just mute that thing for a sec. What do we do? Oh, it's really messes up because I'm using the same browser for both the camera streaming. This is no good, is it? This is no good. What happened to my... Yes, I can popsy check those tools yourself. Where's the stream? Someone's actually asking for like any ideas how to detect emotions, like negative or positive. Please, someone is being polite. That's nice as well. Yes, we said like it's a nice idea. We want a list of emotions, like what emotion, because normally it's like sad, happy, sad, whatever that's been done. Would be interesting, yeah, if someone is like we want to try and make it medical. We're mostly trying to make medical stuff. So if you could like diagnose something from the video footage, that would be nice. But obviously it will be much harder than detecting heart rate. So some say minimal starter set if you want to keep it tight. Categories: neutral, joy, amusement, sadness, anger, fear, anxiety, disgust. Yeah, disgust. You have this disgust, an interesting it's that politician, the American politician that has this like lip thingy going on. So it does like apparently it's like activating some muscles that never get activated otherwise. So they only activate during this sense feeling of disgust. It's like this lip thingy. Is it Dick Cheney? Yeah, Dick Cheney lip. Has this like looks like angry, but it's actually apparently disgust. What else? What is the suggestion? Surprise, contempt, confusion, frustration, boredom. Yeah, boredom is a big one, isn't it? 99% will be boredom. And then dimensions. Okay, that's interesting. Yeah, so we can turn it into a prompt. Just turn it into a prompt, give it to one of the bots to code a web application on that. That's the kind of stuff we do. That's the kind of stuff we do. Wait a sec. Yeah, this video was like from 10, 12 years ago, detecting your heart rate through the camera. The other thing was you can actually detect like minor motion. So it's essentially like a microscope for, video microscope. So this one is also a microscope. It's extracting green light and then looking at variability in the green light to see if, if the blood is pulsating through your face in this case. But you can do the same thing, like if you're looking at the chest, then you can see if someone is, you can do breathing. So whatever respiration rate, which again was done. But yeah, it's one of those things that they work. It works really well, if you, hold your tongue on a right angle and, don't move and don't blink. Like in my case now, it's just generating noise because I keep blinking and stuff. Just blinking non-stop. It's hard not to move, isn't it? Yeah, one of those tools shows you how hard it is not to move. The signal quality there is actually not accurate. So it meant to show you when the spectrum in the frequency domain, like when you have when you're locking. Okay, wait a sec. Spectrum, we mean like frequency spectrum. Someone thought I'm talking about the spectrum, a different type of spectrum. There's many different types of spectrums. This one is specifically talking frequency domains, data processing, data science, processing signal. So you see the time domain, top right, and a frequency domain, top bottom right, which is also called the spectrum of the signal. So you can see what frequencies are dominant. So once it's the quality there, when it's saying quality, currently saying fair, so if I stop moving, hopefully it will start showing quality higher, good or excellent. And that's measuring the signal to noise ratio. So when the spectrum is showing a specific frequency, it's locking on a specific frequency, like now, kind of. So that's when the signal to noise ratio goes higher, and that's what the quality there is trying to show. Yeah, that's the kind of stuff we make. We make those web applications on a YouTube channel, then they go on a website. You can check them out, test it on your face, see what your blood pressure is as you're getting angry or something. See if it's going up or down. Also go and do some push-ups, try to calm down. That helps a lot, we can actually try it right now. My watch is also fluctuating quite a bit. Well, mainly because I'm not wearing it correctly, because I really don't like it like tight on my wrist. So apparently you're meant to have it, well, not too tight because it will block blood circulation, but also not too loose. So it actually measures, again, a higher quality signal. The watch doesn't actually show you what the signal quality is. I mean, they probably could by somehow measuring the signal strength as well, because it's like the light will be escaping whatever if you see a green light in there, means some of the light escaping and the signal quality will be reduced. So same thing here, like the light in the room, if something flashing on my screen will affect the measurement as well. Crazy stuff. Magic of science, camera, pixels on the screen. We are developing on YouTube and we're streaming all the development process. So currently, obviously not developing because yeah. So we develop all the tools on YouTube live. Then they go once they're finished. Well, even prototypes just go on our website, so you can play around, provide feedback, see how it works for you. Okay. Let me check the stream. Yeah, and so back to this idea. So minimal, what is it? Yeah, we should turn it into a prompt. How do we do it? We normally just talk to AI agents. So we'll just ask an AI, whatever, any ideas, we can do it right now. Shall we talk to an agent? Talk to an agent. What's happening? Oh, my system is really annoying. My microphone gain keeps being reduced. I don't know why. Apparently it's like OBS, potentially OBS doing it. Something is doing it. Wait a sec. Right, so someone is asking how does it do it through the webcam? So I know it's hard to believe that's actually working. It's one of those things. uh, it's like I don't know if like people start thinking it's like a conspiracy theory or something like but it's pixels. Then the green light is extracted. On the page, there's actually an explanation of how it does it, like all the technical stuff. All the source code is there as well. So you can, it's JavaScript. So it's extracting green light within the square on my forehead. And then essentially amplifies. So if the green light is going RGB, so if the green light is going from 0 to 255 to 56, whatever it is, then we just we're just extracting that to 255 and looking at fluctuation in the green light. Looking at fluctuations in the green light. So it's not well, it is magic. It's like explainable magic. It's explainable magic. Explainable magic. So you can try it yourself, joining the site. Try it yourself. You can try it on your own face. How good is that? It's pretty amazing. It's pretty amazing. But I forgot to put the link. I forgot to put the link. Because I don't have the chat open as well. Yeah, that's the link to the tool that you can try yourself. Try it yourself. Wait, let me close a few things. Let me close a few things. Yeah, right. So turning this into a prompt. How do we do that? How do we do that? How do we do that? So let me know if you have any specific questions. Oh, come on. If you have any specific questions, do let me know. Should be live. I mean, it's there would be a delay, but it shouldn't be too bad. It would be like a few seconds or so, 5-6 seconds. Yeah, so making those live on our stream. We should be jumping into the code. Yeah, there was a good question about motion. It's called detecting emotions. Could be nice. Could be nice. Could be very nice. I mean, we can just give this whole conversation to Gemini. Whichever model, doesn't really matter. Well, for now, doesn't matter. Later, it will matter. I'll start from start from a more basic model. Give the prompt. Wait, we need a text to speech to text. Speech to text. Where's which one had a good speech to text? Perplexity did. Perplexity did. Can you take this conversation and turn it into, like, summarize this conversation, turn it into a technical brief. Focus on the technical things. Let's take that. Run that. An internal error. What on earth? Why? I don't get it. Don't get it. Why? Let's try it again. Let's try it again. Let's try it again. Yeah, let's actually chat to it for a sec. Let's chat to it. Okay, what do you know about recognizing emotions through using a webcam?
Emotion recognition using webcams employs AI and deep learning to analyze facial expressions and other cues to detect emotions in real time. Technologies like ResNet and AWS recognition are commonly used, with applications ranging from video calls to emotion tracking in software.
Okay, we want to do something simple in JavaScript.
You can use JavaScript with libraries like faceapi.js or tracking.js for emotion recognition in real time. Want a quick code example to get started?
A quick code example. No, wait. Before coding, can we discuss it a bit further? So we're looking at this. So what the list of emotions be like? So we're thinking minimal status set. We want to keep it. Yeah, we want to keep it simple. So the categories should be like neutral, joy, amusement, sadness, anger, fear, anxiety, surprise, contempt, confusion, frustration, boredom. Boredom is a big one. How do you detect boredom? Like surely different. Yeah, how specific? What's the specificity of a tool like this be like? What's the accuracy level? And then can you also mention the different dimensions like valence, arousal, dominance, intensity? So can you talk more about this?
Emotion recognition systems show high accuracy for positive emotions like happiness, 96.42%, and surprise, 96.32%, while emotions like anger and disgust have slightly lower but still high accuracy, around 91% to 94%. The system uses facial features to determine emotions, achieving up to 100% accuracy in some cases. For emotional dimensions, valence gauges positivity or negativity, arousal measures intensity or energy, and dominance indicates control over the emotion, together forming a comprehensive view of emotional states. Would you like help with code examples or further details?
Okay, and what would it look like? What would the web application look like? Would my emotion be written on my forehead?
Typically, a web app for emotion recognition shows your webcam feed with visual indicators, like labels or icons, example joy, neutral, or boredom, overlaid on your face or near it. Sometimes it might highlight facial regions, like the forehead or mouth, where key expressions are detected. Would you like to see an example or more details on implementation?
Would it also like highlight based on what the features in the video footage the determination will be made?
Yes, the application highlights facial features, like eyes, mouth, and eyebrows, where expressions or emotions are detected, using bounding boxes or labels. The system analyzes key facial landmarks, like the distance between eyes or the curvature of the mouth, to determine the emotion and its intensity. Would you like help with setting that up in code?
Yeah, not yet, not coding yet, but just trying to understand what it will look like. So essentially, it will extract features from the face. Would it actually show me which features it's currently looking at, and how the decision, and based on what features the decision was made? Would it actually show me that?
Yes, many emotion recognition systems highlight facial landmarks, such as eyes, mouth, and eyebrows on screen, and often show confidence scores or indicators for each feature. The system uses key points, like eye corners or lip corners, to analyze expressions, making it clear which features influence the decision. Would you like more details or examples of these visualizations?
Now, can you elaborate on that real quick? So what would I see on the, so what the overlay be? So I assume on my face there will be the motion indicator will be written on my forehead or something, and then what else would be shown, and what would be, and do we need any controls? And if we do need any controls, what would they be?
You'll see overlays, like labels showing your detected emotion, and possibly bounding boxes around facial features, eyes, mouth. You might also see confidence levels like Joy.85 and buttons to control the webcam or adjust settings. Essentially, you'll have a clear, interactive UI to track and manage the emotion detection. Would you like examples of such UIs?
Yeah, can you describe the user interface for me real quick?
Sure thing. The UI typically includes a live video feed, emotion labels with confidence scores, and bounding boxes around facial features. You'll also have controls for starting stopping detection, adjusting settings, and viewing emotion trends over time, like graphs. It's basically an intuitive interactive dashboard for real-time emotion tracking. Would you like examples or more details on any part?
So what things would we have to consider when developing a web application like this? What would be the main problems be?
When building an emotion recognition web app, key considerations include accuracy, real-time performance, privacy concerns, and handling varying lighting or facial angles. You'll also need robust error handling and performance optimization to ensure smooth user experience. Would you like help planning out specific features or further details?
Could you elaborate on what controls will we have?
Sure. The controls typically include a start-stop button for capturing webcam feed, settings to adjust detection sensitivity, and possibly a toggle for showing or hiding the overlay. You might also have options to view emotion trends or export data. Would you like to go through more specific examples or features?
Could you summarize it for me real quick?
Sure. Your app would have controls to start-stop detection, adjust sensitivity, toggle overlays, and view or export emotion trends. It's an intuitive interface to manage and monitor emotion recognition. Anything else you need help with?
So the sensitivity, would the sensitivity be adjusted for each parameter? What type of parameters are we looking at? Things like that.
Yes. Sensitivity can often be adjusted for parameters like detection threshold, confidence levels, and facial landmark sensitivity. Typically, sliders or input fields let users tweak these settings to balance sensitivity and accuracy. Would you like examples of how to implement these controls?
Sorry, say that again.
Sure. You can include controls to adjust detection sensitivity, such as thresholds, confidence levels, and landmark sensitivity, using sliders or input fields. This allows users to fine-tune performance and accuracy. Would you like further details on how to build these controls?
Wait, and how do we measure accuracy, signal strength, signal to noise ratio? How do we measure it, and how do we display it on the screen as well?
You can measure accuracy using metrics like precision, recall, and F1 score, often displayed as percentages. Signal strength, or SNR, can be shown as numerical values or bars. These metrics can be overlaid on the video feed or in a status panel. Would you like help with code examples for this?
No coding yet. Eventually, we'll need a brief for developer. We have another experienced developer who will be doing the coding for us, but we need the standalone brief with all the details. What do you think of that?
That sounds like a great idea. A standalone brief should cover the app's purpose, key features, UI/UX elements, performance metrics, and privacy considerations. Would you like help drafting the outline or specific sections of it?
Now, what would the sections be?
The brief should include these sections: 1. Overview. 2. Features and functionality. 3. User interface and experience. 4. Performance metrics, like accuracy and SNR. 5. Privacy and ethical considerations. And 6. Future enhancements or controls. Need help fleshing out any specific part?
Sorry, can you elaborate? Can you repeat that and elaborate on that?
Sure, your brief should have these sections. First, an overview explaining the app's purpose. Second, a features section detailing what it does. Third, you'll outline the user interface, what users see and interact with. Fourth, detail performance metrics like accuracy and signal strength. Fifth, include privacy and ethical considerations. And finally, mention future enhancements or additional controls. Would you like to expand on any particular section?
Okay, there's a couple obvious things. First of all, are we doing it all vanilla JavaScript? Can we do it from scratch, or do we need some libraries for it?
Building from scratch in vanilla JavaScript is possible, but integrating libraries like FaceAppy.js or OpenCV.js can simplify emotion recognition. If you want full control and minimal dependencies, vanilla.js works, but
Sorry,
libraries
say
with...
again?
Sure. In your brief, include these sections. 1. Overview. Describe the app. 2. Features and functionality. What it can do. 3. UI/UX. How the user interacts. 4. Performance metrics like accuracy and SNR. 5. Privacy and ethical considerations. 6. Feature enhancements or controls. Would you like to expand on any part?
Okay, I think we're going in a loop. We are going in a loop. Oh, where is the chat? I need the chat. Okay, so we have the long chat. Why does it say answer skipped? It doesn't have the... It's weird. Okay, can we generate the full standalone brief for the developer? Not sure if it can do it because I think it got rid of all the conversation. Oh, and we had a prompt. Had our own prompts. I forgot about that. Never forget your own prompts. Never forget your own prompts. Never forget your own prompts. Where are they? Remove. No, not this one. Develop. Generate. Yeah, this one. I have a play button. Demo. What would the demo do? No, forget the demo. Working static, simulated data. What else? What else? What else? What else? Wait a sec. Let's see, what else do we need? What else do we need? It says, oh, it's funny. It says like 5 days to set up, 6 days to build the interface, day 11 for testing. Oh, should I? No. The timeline. The demo doesn't make sense, does it? It would be nice to have, but we cannot start the voice chat again with Perplexity, which is a bit unfortunate. We are building a web-based prototype that will visualize real-time motion detection from incoming data, e.g. facial recognition and other biosignals. Well, we don't have EEG and other biosignals. Have to only do facial recognition. The goal is to create clear responsive display. Okay, so currently we only have the webcam camera, so we don't have other biosignals. We don't have EEG as well. Can we also make sure that the actual detected emotion and the quality of the signal is displayed on the forehead or somewhere on the canvas? Yeah, confidence percentage will be good. Confidence intervals. Yeah, what is it? Historical micrograph for emotion changes over the past 30, 60 seconds. That sounds good as well. What else? What else? What else? Okay. Yeah, we are using AI. We're having Gemini will be coding. We're talking currently with Perplexity, trying to set the whole brief for developer. So it's meant to be standalone. Ideally, just doing JavaScript, but it is suggesting some libraries. Can you elaborate on the libraries used? Can we just do it in vanilla JavaScript at all, or do we have to use the libraries? And what else? What else? What else? What else? Yeah, we're hosting locally. We'll host locally if that's okay by you. Then it will be available on our website, BioniChaos.com. It always messes up the name. I'll remove the last sentence. I'll remove the last sentence. Okay, let's start with this. Let's start with this one. See how we go. Let's start with this one. See how we go. Okay, so it's regenerated. Let's see. We are building a local webcam-based real-time motion visualization prototype. The system detects facial emotions directly from the webcam feed, displays the detected emotion, for example, happy or neutral, overlays a confidence percentage or signal quality indicator on forehead or top of the frame. That's fine. What else? And shows a rolling micrograph of emotional change over the last 36 seconds. Okay, that's very specific. I think it's got messed up with 30 to 60 seconds. Okay. Browser-based, runs fully offline. That would be an interesting one. Not sure about that. Clear visual feedback on detection, confidence, and emotion trends. Yep. Right, so yeah, we ideally run it locally without any third-party libraries, but we'll see how we go with that. We will see how we go with that. Status. So, do we really need a stop webcam button? Do we really need? Let me mute something. Okay, we can keep going quietly. That's nice. So I'll have emotion, happy, confidence, 94%, timestamps. And with timestamp. Not sure about that. We'll have happy, sad, angry, neutral, surprised. Okay. Not sure if it's seem to be overly complicated. Yeah, everything runs locally with no external data calls, relying solely on the user's webcam. That would be nice. That would be really nice. That would be nice. That would be nice. A developer timeline. A sample pseudocode. No. Can build this fully vanilla JavaScript, including webcam face detection, overlay drawing, and train graph, though Face API JS accelerates model handling for emotion detection. Face API. So this was done already. Okay, can you elaborate on Face API and convince me why I should be using it as opposed to vanilla JavaScript? Let's see what it says. Let's see what it says. There is no text to... we could generate a conversation out of it. Let's actually try a perplexity for the conversation. We can try that. We can try that. What's called the... generate. We have two speakers. They have names. They do have names, even though they're just robots. They do have names. They're pretty good. There's nice names. And we need to choose voices for them as well. We need to choose voices. Okay. Okay, let's generate that. Oh, that's a very long generation for just essentially avoiding reading Gemini response, not Gemini perplexity response. Which model? Do they have their own models or how do they work? Not sure. Not sure. Do we care? Well, not really. The response seem legit. Right, so the good thing about Face API is that it operates locally as opposed to other emotion APIs. So we're not sending frames. With Face API JS, we're not sending frames. So that's kind of nice. Okay, we probably can write two scripts, one with using Face API JS and another one using vanilla JavaScript. How does that sound? How does that sound? And then we will go for development. Do it AI Studio to make sure it's 2.5 Pro. 2.5, 2.5, 2.5 Pro. 2.5, 2.5, 2.5 Pro. Okay, we'll regenerate.
So I've been working on this browser-based emotion detection system using faceapi.js. You're making a machine that can tell when I'm sad? Oh, good, another one. My toaster already gives me judgmental looks. It's not judging you, it's quantifying you. Think of it like an emotional mirror that tells you how expressive your forehead is. Quantifying my forehead? That's all I've ever wanted in life. Please tell me I'm at least scoring high in bewildered charm. Possibly. The model tracks emotions, happiness, prize, anger, sadness, and gives each a confidence value. A confidence value. So my face gets a report card? Yogic smile, 72%. Could do better. Needs more sincerity. Exactly. It runs in real time through your webcam, draws a bounding box around your face, then overlays your dominant emotion. Oh, so my forehead's gonna become Times Square for feelings? Fantastic. Can I rent out ad space for sarcasm? Technically, yes. It's all rendered on a canvas. You could flash loading emotions. Please wait while you think of a punchline. You know what's dangerous about that? Comics pause for effect. Now the computer will think we're clinically depressed between jokes. That is a valid concern. The API updates every frame, so if your face goes neutral mid-joke, it might tag you as mild despair. That's not a bug, that's my career. Touché. But it actually gets pretty accurate once the lighting's balanced. The confidence score tells how sure the model is that you're happy, or fuming. So if the confidence drops, I just yell at the screen until it's sure again. Perfect. Emotional calibration through rage. You joke, but that's almost how we test robustness. Misha, I love you, but your idea of fun sounds like a haunted therapy session with spreadsheets. Well, we also plot a 36-second micrograph of your emotional state over time. A micrograph? So basically a heartbeat monitor, but for vibes. Great. Now I can visually watch my optimism die on stage. It's science. Seeing your emotional fluctuations helps you tune performance patterns. Or it helps me realize audiences trigger disgust spikes. Either way, finally, data-driven comedy. Yep, you'll know exactly when a joke tanks, quantitatively. Perfect. I'll tell the machine, mark that moment as trauma, 98% confidence. And I'll gladly put that in the training dataset. Brilliant. The world's first emotionally aware comedian, powered by Misha's forehead analytics.
Okay, so we didn't give it the prompt of doing everything in a single HTML. Need everything in a single HTML, don't we? And also no React, TypeScript, Tailwind, CSS, Google APIs. We actually need to adjust the prompt based on priority. So interactive, yep, works with keyboard, includes notification. Maybe. Yeah, well, struggling with that one. The canvas should be a specific size. Wait, it's a simulation game canvas, including controls. should be 80% of the viewable height. Yeah, how to use overview. Yeah, the showcasing, the demo mode doesn't make sense in this for this web application. How would you do demo mode for it? Yeah, how would you do demo mode for something like this? Yes, we'll reduce that priority down. We will turn that priority down for the demo mode. Demo mode enhanced, start automatically. Yeah, keep in single file. That would be an important one. That would be a single HTML file. So we'll keep everything in a single HTML script file. That sounds good. Let's go back to okay, let's try that. We added our existing prompt. What is it doing? What is it doing? Layout design, yep, single HTML. Interactive behavior. Toggle sound, okay, whatever. Yes, we want to handle touch events. What? It's now went generic. It's not actually talking about. It's not talking about what we discussed. Wait. Motion? Motion? Yeah, funny. The last response doesn't have any emotion in it. Doesn't have any emotion in it. Hey, that's a bit odd. That's very odd. Why does it do it? Why does it do it? Why does it do it? Wait, I have to mute something. I have to mute something. Face tracking. Yeah, we're doing face tracking, detection, expression, certification, and classification model. Wait, Yeah, expression classification model. Oh, generates the law. So still on this, right? Expression classification. Webcam. Web app. Not sure now it's hallucinating on me because yeah, we want to make sure the emotion is still there and the emotion stuff. Build a fully self-contained single HTML web app that simulates facial expression classification results interactively. Well, wait. We need for it to actually classify. There would be no results. Hey, can you elaborate? What do you mean by results? We don't have any results. We want to do the expression classification based on our own webcam. So the canvas should just turn the camera, and then we should have an overlay of classifying results. We could train a model ourselves. So yeah, so the big question obviously is what model do we use for this? Are we training one from scratch? Can we do something basic using JavaScript? Or do we need to use a big model, like, pre-trained model? Do we need both? Do we need like a pre-trained and then fine-tune based on my face or something? Can you elaborate on that? Let's see. Let's see. Shall we give it to the professional podcasters? Let's give it to the podcasters. Yeah, talking about the pre-training or post-training or fine-tuning. Okay, we have to run that.
Hey Yogic, so I'm trying to get this webcam expression classifier off the ground. Detect emotions live and slap the label right on the person's forehead, kind of like a mood ring, but digital. So, no mood ring, but a mood face. And you want it to say, hey, you look grumpy in real time. Exactly. But here's the kicker. We don't have any pre-labeled data or fancy sensors, just a plain old webcam. Now, the big question, do we build the model from scratch or use some pre-trained behemoth? Ha! Build from scratch? You mean like teaching a baby to recognize emotions, except the baby is your laptop. More or less. But training a model from zero means tons of photos, lots of compute power, and a PhD or two. Vanilla JavaScript won't cut it for deep learning. It's not made for crunching neural nets or training CNNs live in the browser. Okay, so the baby idea is out. What next? The gigantic pre-trained model? Does my laptop need a gym membership for that? Not necessarily. Some lightweight pre-trained models exist, like in faceapi.js. They're optimized to run right in your browser with WebGL acceleration, so you get good accuracy without needing a supercomputer or internet connection. Fancy. So I get a model that's ready to go. Can it say things like happy, sad, or man who's had too much coffee? Pretty much. Plus, it gives you confidence scores, so if it's not sure whether you're angry or just squinting in the sun, it can show that uncertainty, and you can display that confidence as an overlay on the video feed. Sounds like magic. But what if it thinks I'm surprised when I'm just yawning? That's where fine-tuning comes in. You can take that general pre-trained model and train it a little more using your own face data. It helps personalize accuracy, but it's a bit advanced and requires some extra work. So I don't have to reinvent the wheel, just grease the existing one a bit. Exactly. Starting with a pre-trained model is like borrowing a car and tuning it to your style rather than building the engine and frame from scratch. And all this fancy driving tech runs in vanilla JavaScript without React or other frameworks stealing the show? Yes. Pure.js plus libraries like TensorFlow.js or FaceAPI.js handle the heavy lifting. The rest is just overlaying labels, drawing on canvas, and managing webcam access, all doable natively.
I'm sold. So soon I'll have a webcam that not only spies on me, but tells me when I look like a grumpy cat?
That's the vision. A little fun with tech and a lot of smiles, literally.
Just remind me to keep my poker face. Wouldn't want the camera outing my secret emotion. Hungry again. Deal. Just don't forget to smile for the algorithm. Will do. But if it calls me confused, I blame you. Fair enough. That's data science humor for you.
Yeah, that was actually pretty good. But we still need to decide, are we doing pre-train, training from scratch, fine-tuning, or vanilla JS, which is essentially training from scratch. So this, so vanilla JS will be, simple code, but low accuracy, fine-tuning, requires some training infrastructure, which we have. So that will have a better accuracy for our specific context. Okay, training from scratch, build and train your own model from dataset. So we don't have a dataset. So we need some sort of basic labeling. Are we gonna be labeling? Wait, and the pre-trained, so the face API. Okay, so question, can we do a combination of being able to fine tune but start with face API, and can you check if face API actually has training on this already or not? Like, is it trained on facial expressions already, or do we need to do something special with it? Fine tune, start with Face API, check Face API. What do we need? We haven't started generating the code yet, which has been unfortunate. Which is a bit unfortunate. So it says that the Face API indeed comes with a pre-trained model, specifically for facial expression recognition. Okay. Can detect emotions such as happy, angry, surprised, neutral, and more directly from webcam input without requiring you to train a model from scratch. This is a lightweight, around 310 kilobytes. Okay, fast, reasonably accurate. So we might need to fine tune it or something. Running entirely in browser using TensorFlow.js with a WebGL acceleration. So that's essentially what we're doing currently already. Regarding fine-tuning out of the box, Face API does not natively provide tools for end-user fine-tuning of its model directly within the browser. It's primarily designed to use the fixed pre-trained weights for interface. However, you could potentially build fine-tuning pipeline externally. Maybe. A custom model into the browser. So we could pre-train it. Can we train on JavaScript? Like, should be able to train in the browser as well. Oh, yeah. Yep. Okay, so Face API. Okay, so Face API it is. Okay, so we need a brief for developer to, yeah, we will go with Face API. See how well it's working. But then we might want to add the functionality to fine tune in the browser, if that's possible. Surely it is possible to do some basic fine tuning. There is no ready-made browser. For a starting point, a typical expression classification pre-trained model. Tip. Yeah, we need that brief. No code. Detailed. Detailed brief for developer. Detailed brief for developer. Technical guidelines. It's funny how it does like different faces for developers if it's not AI developing it. Live emotion detection, overlay. Sounds good. Yeah, we should have everything needed to run it. Robust. The brief should empower the developer to build a robust foundation using Face API. So the expected outcomes: working webcam UI, live emotion detection overlay, interactive toggles, smooth experience on all devices, proof of concept fine-tuning. Okay. Developer brief. Let's just go for it. I'm not gonna read all of this. Hey, can you generate the code as well? We'll ask Perplexity to generate it as well, but Gemini 2.5 generally should be better, so we could have two versions compared between them. Expression. Let's call it expression. Or do you have any better name suggestions for it? Any better names? Face Express. Face Express. Face Express. Face Express is not bad. And we need an index. HTML. Index. Index. We need an index. HTML. How long is this code? It looks too short. It's way too short. Way too short. On my head is my heart rate. How does it detect it on my head? Using the webcam. No sensors. Well, so if I don't move, currently it should be 71. Well, my smartwatch is also fluctuating quite a bit. 74. We'll say 70 something. Between 72 to 74. So if I don't move, it might actually do a good reading. Because I have enough light. Some natural light. Natural light helps. There's a question if we came up with it all by ourselves. No, there's a TED Talk YouTube video from like 15 years ago about this. It's to do with camera like amplification. So it's essentially amplifying, in this case it's amplifying the green channel changes. Because when you're blood pulsing through your face, you could actually see it. But they're also talking about, and this is something we might do as well. Well, currently we're doing a facial expression detection, again using webcam. And we're gonna be, apparently there's a pre-trained face API JavaScript pre-trained model. But the other thing you can do like a respiration rate by looking at so essentially minor movement in the camera footage. Again, if you're not moving, in this case I also should not be moving, then it can actually detect the slight changes in color of my face. But also if you're not moving, it could also detect respiration rate by looking at your chest. But again, if you're like sleeping or something, nothing else is moving, light is not changing, the camera is good, you hold your tongue on the right angle. And we're doing all this live, all the development is happening live on YouTube. If something is working, even if it doesn't work, it then goes on to our website, BioniChaos.com. Yeah, BioniChaos, single C, BioniChaos.com. If I spell it out, I never, the text to speech, let's text, BioniChaos.com. It can never get it correctly. Can you go to the website called BioniChaos.com? Yeah, so it did a good job, but it's always, yeah, if I talk clearly like that, it's still putting double C. So the actual website has a single C in it. Single C. But yeah, we're not gonna pay for another domain. Because it's just a waste of time. It is what it is. The YouTube channel is the same, has the same name. The YouTube channel, and we are live streaming, like I'm live streaming my face and my other screen, which has the website at the moment. Hopefully soon enough, if Gemini 2.5 Pro, let's see, generates a decent code, we could webcam face detection. Oh, the camera won't work because I'm using it for this. Oh, it's one of those. Oh wait, no, it should work. It should work. We can do it. We can do it. Start detection. We can do it. Nah, this is, yeah. So perplexity is hopeless. I don't know what model it's actually using. It's hopeless. Anyway, we'll get rid of it. We'll get rid of perplexity code. We have a much longer code generated by Gemini 2.5 Pro. Yeah, the previous one was only 160 lines of JavaScript. This one is 563 lines. So this sounds more like it. API, the Face API. The link for Face API JS is wrong, obviously. Error loading models. Please check console. Yeah, so that WebGL. We meant to be using the graphic accelerator, whatever, on this machine, unless it's actually being taken over by something else. Sometimes we'll see. So platform browser has already been set. CPU backend, blah blah blah. WebGL. Yep. But there's a problem with the Web Express models. Tiny face detector model is not there. So obviously the link, Google, Gemini hallucinated the link. Well, that's mainly because it doesn't have grounding with Google search, whatever. So let's ground it with Google search and find the correct link. I think that's what the problem is. Must be. Just give it all the error code from the browser. To grounding with Google search, so it actually finds. I know that this is not the main focus, but what is your opinion on use of EEG for games? So it's great. That's my opinion is only positive. I'm doing a lot of EEG stuff on this channel because I actually have like about 8 years of EEG, whatever experience. So EEG is the way to go. Yeah, I actually have this like modality thing, because someone was asking a similar question. So yeah, gaming, just go for it, whatever. But yeah, I have this neuromodality thing, so you can see if you go category neuro. Yeah, so essentially, yeah, so gaming is fine. I didn't do any gaming. Well, I don't have any EEG headsets. I would probably have a headset for like a prototype headset that I could record with, but that's that would be not good enough, would it? A prototype headset would not be good enough. So you have your what's called like yeah, so here wait, blah blah wait, remove cardio, visual, audio, muscle, and AVA, and you're left with a lot of EEG devices. So you have like temporal resolution and spatial resolution. So neuro, so yeah, fMRI, ignore fMRI, TMS, ignore TMS, EEG. So you have wearables, DBS, EEG, high density. Yeah, so you could, well, currently EEG is just these two. You could potentially have much more. You could potentially have much more. But essentially something like that for gaming should be totally fine. I call them wearable toys. And then you need the clinical grade or research grade stuff. And my camera is actually hiding the view. So that's not good, that's not good, that's not good. We'll have to repeat it all again. Anyhow, we can check the tool. I can talk more about it if you actually check the website. I'll pop it in the chat. But yeah, gaming. Let's get back to this for a sec. Did Gemini respond? No, we forgot to send the prompt. That's not cool. Okay, we'll send those errors. It has now grounding with Google search, so it should in theory find the correct face API link. Maybe. I'm sure I lost someone. We potentially had someone joining the stream, but I lost them. Maybe they can give a call on the other platform. Don't know. Anyhow, yeah, check out everything you do in those live streams eventually appearing on BioniChaos.com. Go check out the website, provide your feedback. A lot of it on EEG stuff. So if you go, well, neurology will have MRI simulations and things like that, TMS, whatever. You can also type, you can go all tools, type EEG, it will be better. So you have, yeah, this is probably the most prominent one of all is this EEG signal simulator, so you can simulate your own synthetic signal. The problem with this page, it doesn't fit the screen. That's not good, is it? That's not good. If I go 50%, it kind of does. So you can choose your brain state. What's your brain state at the moment? Do you know what's your brain state? Right, so for the previous thing, we had to actually download the Face API locally. We had to download the Face API locally, and then it's also has models. What on earth? How does that work? Not sure. By the way, yep. This is common classic setup, analysis of the error, not found, JSON not found. This is meant to be links to it. This is a URL path where we're looking for the file face express. Wait. Yeah, don't have the models. Let's have a... So I meant to have the models locally. Mueller. Do I need the models locally? Nah, that's weird. Hey, let's bring in our model. Let's try the new chat with Perplexity. Hey, can you give me one sentence on Face API JS version? What is it? Just in 1 or 2 sentences.
The latest version of FaceAPI.js is 0.22.2, which includes updates like TensorFlow.js version 1.7.0. You can find more details on the GitHub releases page.
Okay, so I have a HTML with JavaScript that's using Face API JS. Do I need to download the models locally or not?
Yes, you need to download the model files locally for face-api.js. They're typically placed in a weights folder you load from your project. Would you like help with how to set that up?
Can you double check that? Like, so if I have like a models folder, what should be in the folder? This should
Yes.
be face landmarks or something else.
The model files for faceapi.js should be placed in a folder, often named models, and include files like manifest.json and the weight files. Shards, for example, you might have tiny face detector, face landmark 68net, face recognition net, and so on in that directory. Then you load them in your code using something like faceapi.load tiny face detector model /models.
Can you check how big the whole the whole model is?
The face landmark 68 model is about 350 KB. The tiny model is around 80 KB, and the full face recognition model is roughly 6.2 megabytes. Would you like further details on specific models?
And I must have them like, so wait, so I have to have them locally, is that correct?
Yes, you need to host the model files locally, such as in a models folder, and load them using functions like faceap.load tiny face detector models. Would you like help with setting up that folder or loading them?
Can I download them through a terminal, a Linux terminal?
Yes, you can clone the repository containing the models and move them to your project. For example, 1. Run git clone https github.com/justadude-who-hacks faceapi.js.2. Then move the models folder with mv faceapi.js weights /
Did you say the dude that hacks? Why, when you have a discussion, can you repeat the last response? With Perplexity, it doesn't save the responses. I expected the responses to be face API load face landmark model into models. Generally, the models localized should be stored. Blah blah blah. How do you actually? Thanks for your feedback on the EG. Came across a YouTube channel called New Game. Yeah, I wouldn't touch the Muse though, but yeah, I think I know that channel. Yeah, I have them on LinkedIn or something. I'm working on an academic project combining computer vision and EEG to create a game that integrates MetaQuest using EEG input. Yeah, I know a lot of people who do the same thing. Not a lot, but I know someone else who does it. Yeah. I'm into simulating stuff, so whatever we can simulate. Because I mean, we live in a metaverse, right? So we live in a simulation, so should be able just to simulate things first before going buying whatever servers, equipment, VR. Yeah, it's always about. Yeah, no, I mean forgetting all the names, whatever. But someone is already doing it. EEG with computer vision and VR and what's not. Yeah, just one of those no-brainers. Something obvious. Can you explain where do I run the wait function? Do I need to do it just once in my JavaScript code, or can I just do something in the terminal? What's the purpose of using EEG to begin with? Like, I mean, most of the time you're getting really noisy data. Most of the time the data is super, super duper duper noisy. Like in this example, you are having eye blinks through the roof. Depends where the electrodes are, obviously, or you have your EMG, a muscle contaminating the signal. So you really like most of those gaming, like the Muse, the signal to noise ratio of the Muse, my educated guess would be very, very low. If you want, I can try putting a number to it. But yeah, it will be very low. So you would be lucky if you have any EEG in the signal at all. After whatever the first 10 minutes of recording when you sit still. It's same for my face, whatever, for detecting heart rate from your camera and stuff. Yeah, it works really well when you sit still. You don't move, you don't do anything for some time, and you keep sitting still, not moving and not doing anything, then you can record a high quality signal. Once something goes wrong, and with wearable EEG wearables, there's a lot that can go wrong, then you just you'll be just out of it. Out of it, out of it, out of it, out of it. Out of it. Where was the beat on? Where was the beat on? Getting the model. So you must run the await function inside the asynchronous JavaScript function marked with async keyword. Never directly in the terminal or outside the async context. Typically, you call your async function once in your JavaScript code, for example, during the page load. To load models. Wait, that's assuming the model's already there. Wait, what are we talking about? Okay, so I don't have the models yet. Are you talking about when the models are already in the model folder, or what? You need to have the models already downloaded and placed in your models folder before running the weight loading function. The models are pre-trained and come as a set of files. Yes, so how in the terminal do I fetch, how do I download the models using Linux terminal? Oh, going in circles a bit. Right, winget. That sounds more like it. Git clone. Yeah, I want to download from URL directly. How do I know the names? Wait, in this case, am I supposed to know the names of the files, or would it just download all the files or something? How does it work? How does it work? Going in a loop, we're going in a loop. Guess we have git clone. What is it? Back to EEG. Based on your input about EEG noise, I think we could explore using EEG and MetaQuest to create. Yeah, I would not even go there. It's just the cost benefit is not worth it. I mean, the main cost is spending time on, essentially dealing with noise. I don't know about MetaQuest, but yeah, the Muse. Forget about it. To create an immersive meditation app where the environment changes according to the user's detected mental state. Well, that's essentially what we're trying to do at the moment, but just using a webcam. So you can do a lot with a web camera. The Muse has a few channels, just a bugger all number of channels. So through a webcam, you get way more data, even through a basic webcam that anyone has. So in terms of meditation, you can do way more there. Everyone also has a screen, so you could also replace the Meta Quest as well. How good is that? How good is that? Wait a sec. Yeah, the budget, what you save now. If you really need EEG, most of the time you probably don't, unless you trying to diagnose epilepsy. That's probably the only, well, clinical reason I can think of where you actually need EEG. Well, then you need a clinical grade device as well. For any other reasons, well, yeah, just gaming. Use what you've got. I mean, if you already got the Muse, like, I mean, if I had the Muse, yeah, probably, what would I do with a Muse? Even if it's a Muse 2 headband, which is meant to be much better, I will probably record from it for 10 minutes, show how the signal to noise ratio is very bad, and then probably just disassemble it and throw it away. Make a YouTube video, one video on it, and out. So I don't know how much does it cost. It's not worth it. If I was to be sent one for free, then yeah, again, it's 10 minutes recording, 10 minutes teardown, and out into the landfill of diagnostic devices, wearables. You have too many of. Too many. Wait a sec. Yeah, so we're streaming on YouTube, we're doing web development, sharing another app we made before, EEG, signal generator. Also, yeah, so we live stream all the development process on YouTube, as you can tell. And by the end of the stream, whatever we make goes onto our website, BioniChaos.com. Can search for EEG. Have a demo of a prosthetic arm. Wait, what? Yeah, making simulations like that. Making simulations like that. So if you have any specific questions, especially after checking the website, do let us know. We're trying to recognize facial expressions through a webcam. Apparently there's already a model for it. Yeah, sorry for the audio. I'm jumping around between. Check folder location. Yeah, so anyway, we need the model. We need the model locally. We'll try to download it right now. Should be easy. Should be easy if you are a whatever data engineer. I'm not a data engineer. I'm like a data scientist, whatever. So nothing is easy for me, technically wise. Nothing is easy because we need to get that face API from somewhere. Need to get the face API from somewhere. From somewhere. Because we need it locally. And we should have a command for it. Can use wget. Should we? Is it really on github.com just a dude who hacks face API? Really? Is that the name? Is that really the name of the of the repo? Hope not. Hope not. Hope not. Ah. Oh, it's really weird because the YouTube studio is telling me that there is no one in the stream, but actually there is because we got a comment. Sharing EEG simulator, by the way, do you have that project repo on GitHub? So we don't do GitHub. Everything we do is on the website. So all the code, specifically for this one, should be like in the past we used to have a backend. Currently we're trying not to have backends. So just JavaScript. Therefore, something like this. Sorry. Is something like this. The code should just be on the side. So if you go console sources, e.g. synth, that is it. All the code should be there. So it's 1,000 lines of code. All the JavaScript is there. It's a standalone, so there is nothing else, well, except some Google Analytics stuff, which are not relevant to the page. Literally, if you take this HTML with the JavaScript and everything, you can run it anywhere you like on your, including your own website or something. Including your own website. So it's open source in that sense. And no, we don't use GitHub, just for the convenience, the complexity of it. Just another thing to manage. We did have a repo there, but just too hard. Too hard. Too hard. And YouTube Studio doesn't need a refreshing or something. No, it still tells me provides me incorrect information. Ah, like in one place there's yeah, it's showing different. No, so it doesn't have a backend. This one we had the previous things before they did have a backend. This one doesn't, because we, you know, most things don't. I don't need a backend. I think if you have a backend, probably doing something wrong. No, it's like too complicated. So it doesn't have to be complicated. It doesn't have to be complicated. Most things are pretty simple. Well, at least in my head. At least in my head. Thanks for questions and take showing interest. That's really amazing, really encouraging, really encouraging. Really encouraging. Well, how about that Claude? Okay, so that GitHub, just a dude who hacks. So is that the only place that has the Google, the Face API thing hosted on? I don't get it. Sounds like a very bad name. Okay, Vincent Mueller. Okay. Looks legit. Looks legit. Looks legit. Looks legit. Looks legit. Face API. Full 17,000 stars on GitHub. That's decent. That's decent. Face API. Face recognition JS, simple Node.js package for robust face detection and face recognition. So when we're doing face recognition, so the face API detection and face recognition in the browser in Node.js TensorFlow. Okay, what's the difference between them then? Except the star count. One has 2,000 and one has 17,000. So obviously, but what's the difference otherwise? Obviously, Face.js is more popular. What's called? No, Face API JS. Phew. License. Okay, it has a nice. So detecting your age, that's interesting. Because we can do a lot with age. I was thinking of a web application where you can, like, with a slider, change your age. So do like, make yourself older or younger. For educational purposes only, obviously. That will be a big disclaimer. Because who knows what else people will be using it for. Yeah, thanks. Thank you for joining in. If you want to join in the streams, you're more than welcome. Can chat or bring you live with whatever voice or camera, whatever. Wait, how does it do celebrity recognition? So it was trained on age. Oh, the Face API is weird. Yeah, and it has expression recognition. So it has surprised, disgusted, fearful, sad, angry, happy. That's nice. That's nice. Very nice. One sec. Oops, sorry, I forgot to. Okay, what were we doing? So the face, yeah, the Face API, Face API, Face API, Face API, Face API. Yeah, anyway, it looks promising. How about a simple? Wait, so did Gemini? Okay, wait. Let's use GitHub Copilot for this. Let's use GitHub Copilot for this. Face Express. We have the HTML. Apparently, focus. Should have a folder. Okay, let's give it to GitHub Copilot for a sec. Claude. Let's do Claude. That's fine. Agent mode. Okay, whatever. Well, probably, yeah, the problem with agent mode is that it's just chewing up tokens like there's no tomorrow. Can you check what's missing? So we actually need to be able to download the model locally, don't we? Because we currently don't have it. Can you guide me through that? How do we fetch the model? Or just do it yourself? Agent can do it, can take control of your terminal as well. Good luck to us all. Yep. Yeah, so it's running. Yeah, it's helping us setting it up. Hey, Claude. Ooh, really? Wait, there's a lot. It's telling. There's weights. Yeah, so it's from that GitHub repo, Face API.js, face recognition model, weights, face expression, face recognition, face expression. Okay, it sounds face landmark. I don't think this will be correct because it doesn't have the like internet connection, this thing. Let's actually check the repo again. Wait. How do we download the whole thing? Features. Yeah, so there's a face recognition, face landmark. Why do we need the landmark? We're using Google for that. Face expression, age estimation, and gender recognition. Wow, okay. Yeah, it's nice. It's giving you the like the gender and then confidence, degrees of confidence, which is nice. Very nice. Surprisingly, it doesn't do it for age. So age should also come with confidence levels. Probably. What? Face API.js for browser. We can install it via npm. Node.js. Oh, it's complicated. Why is it so complicated? Okay, we'll just let the bot do its thing. So it's downloading stuff. Great, we downloaded. Yeah, we have the models. Start the local server. Webcam models loaded successfully. Where's the webcam? Okay, start webcam. Okay, neutral. Neutral. Happy. Okay. What do you know? It actually works. Let's show it something else. Can we show it something else? Some celebrities or something. Do they have this smiley? They have this stress ball with a smiley face on it. No, there's nothing. There's nothing I can show it. But is it? Okay, WebGL. Is it actually using the WebGL? 200 megabytes. Yes, sometimes the models, if they were loaded into, if they were loaded, yes, I don't know. Anyway, it's working. Hide confidence. No, we need confidence. Correct the motion. Right. So yeah. So does it? So when we're doing this supposedly training, when we're doing ready to train. I think it's just a mock-up. I think. Surprised. Yeah. So it's all wrong. Angry? Are you angry? It's fluctuating too much for me to tell. It's fluctuating too much. Fluctuating too much. I'll make it available for you eventually. We will make it available for you eventually. Angry. It's always showing that my face is angry. It's always showing angry. Fine tuning. This is an advanced proof of concept feature. You can provide labeled samples to train a new mini classifier on top of the face API feature extractor. This does not modify the original model but can adapt to your specific expressions. So where it will be actually saved? Let's capture sample, train custom model. the buttons are there. Ooh. Wait, I can't even. So when I hit train custom model, please collect at least 10 samples before training. Okay. The question, where does it? Okay, so set. We're doing set phase. Doing. Oh. Set phase. Okay, we have 12 set phase. Training in progress. This may take a moment. Okay, is it fake or why does it why do I think it's fake? Why do I think it's fake? Why do I think training in progress? This might take a moment. Any console problem Mueller. What's going on? What's going on? What is going on? Wait a sec. Where's this noise coming from? Wait, what? There's something wrong. There is something wrong. There is something wrong. What's the age detection? It doesn't do my age. Oh, come on. Wait, there's something wrong with my desktop audio. Desktop audio. Some noise coming from somewhere. What? This is generating some. Wait. It's generating some noise. What's it generating noise for? Right, now it's better. Whew. It didn't turn on. I enabled sonification and then it was not disabling it. It was not disabling it. Let me know if there's any questions, especially after visiting the website. I'm happy to open any of those tools. or change something. Probably changes will go into a new version. So it will be like whatever, forking it, splitting it. You know what I mean? can be happy only certain percentage. This is 100% happy. This is like 90%. That's, we could do all of them. We can do all of them. We'll have neutral, happy, sad, angry, surprised, disgusted, fearful. It's not, it's surprised. How do you do fearful? No. I don't know. How do you do it? Fearful. No, still surprised. I can't do fearful face. You can do it in acting. Use it in acting school. Your fearful face. Fearful face. How do you do fearful face? Give me your best fearful face. So it will be running on our website. That's the good thing. And you could be potentially fine-tuning it. So if you can train it on your own face. 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 But let. Yes, it seems like the facial thing is only using 48 megabytes, but the blood circulation thing is using a whopping 4.6 gigabytes. So I don't think it's using WebGL. That might be a problem. Might be a problem. It's not using WebGL. Let me restart it for a sec. Yeah, 48 megabytes. This one doesn't say. Is it because it's bugger all or something's wrong? This one's running locally, obviously. We haven't deployed it on the website yet, but we'll deploy it so you can use it yourself. Yeah, it's still using 4.6. Wait, let's Control F5 it. It's funny how you can be happy only a certain percentage out of 100%. Can be only like 70% happy. Are you only 70% happy? Are you 100%? Are you 100% happy or just a little bit? Surprise is only 99%. 99% surprised. 99% surprised. Look, you look like 50% angry. Can you be like less angry, like just a little bit angry? No, it's fluctuating quite a bit. I can't get it. This one is using 4.6 gigabytes in the browser. That's not great. That's not great. What else should we do? So I don't know. I guess we answered that question about face recognition. Well, not we, but this GitHub repo did. Face API JS. We're just using it because it's open source. We love open source. We love open source. Supposedly it should be able to do age. I like how Vincent, non-Vincent. How did the face recognition? It was trained on celebrities as well. Face expression, age. Why doesn't it show my age? Anyhow, we'll continue this next time. Don't forget to like, subscribe, comment. You know what to do. And go check the website. Everything we do is eventually on BioniChaos.com. Go check it out, provide your feedback. Bye.